IPv6 Prefix Delegation. If you're wondering, what exactly is that? You've come to the right place. Let's begin. Our objective for you and I in this MicroNugget is simple. We want to take a look at the world of prefix delegation to understand why it's used, how to configure it, and also verify that it's working. See, a service provider does something amazing for a living. They provide service. And an internet service provider, if this is us, and we've been assigned this block of addresses, we can then take from that block space, we can hand out addresses to our customers. Not only are we going to hand out individual IP addresses, but we can also hand out entire networks to our customers. So if we have a customer that needs maybe, let's say they need 100 subnets for this customer, we could just hand them over a network and say, you know what, here's a block of addresses, go ahead and carve that up any way you need to. For example, maybe we'll hand them a /56-bit network, and that gives them 8 more bits to play with up to the 64-bit boundary. Because normally with IPv6, we're going to have at the end of the day a 64-bit prefix and a 64-bit interface ID or a host ID. After planning on what IP addresses we're going to hand out, one of the methods, not the only method, but one of the methods of actually delivering that information of what networks they can use is through prefix delegation. And it's almost magic. It goes something like this. We make the customer's router, this is the customer edge, and this is the provider edge. We make this customer edge, we make him a DHCP client. But he's not after an IP address for himself. He's going to make a prefix delegation request. When that request hits the provider edge, who we've configured, is going to say, yeah, I've got a beautiful network for you. Here you go. And then this router can take that prefix that he's been delegated and use it on his internal networks. We can also do further prefix delegation inward in a larger network. But for this example, let's say that R10 wants to receive one network, a /56, and then go ahead and take that and divide it among 2 or more internal interfaces. Well, that's the game of prefix delegation, and it really involves a couple basic things. We have to train the DHCP server, in this case a prefix delegation DHCP server, of what addresses it should hand out, and we also need to train R10 to go ahead and ask for an address and use the address he receives on his internal interfaces. To make this work, we're going to have to identify the pools of addresses that we want to use and configure those pools as part of a DHCP plan to allocate those to our customer. At the customer site, they're going to have to tell the internal interfaces to go ahead and use the address that was received. The configuration is pretty straightforward. Let's do it right now. On R4, which is our DHCP server, he doesn't have much of a configuration at all on the interface that goes off to the customer edge. So let's do a couple basic things. Let's create a local pool that identifies the range of addresses that we want to hand out. I'm basically saying that from the /49, I want to hand out 56-bit network spaces out to clients. We're going to call on that pool in just a moment. Then we're going to create a DHCP pool that says, you know what, I want to do prefix delegation referring to the local pool. And I want to lease this out forever. The client can have it for as long as they exist. Then we're going to go into interface configuration mode for gig 2/0. I'm going to assign a MAC address because I like to do that for packet capture so I can look at the traffic and verify who a device is. I'm going to specify an IPv6 global address, a link local address, just because I like to hard code them because I can't stand EUI64, not on network devices anyway. And then we're going to specify that pool. This is the critical part. We want to tell this interface that it should pay attention to DHCP requests and link those requests to that pool that we just created. I'm also going to bring the interface up with a no shutdown command. And let's do a show. I should probably put a do in front of that. So let's do a do show IPv6 local pool. And this says we have 128 networks that we can get from this. Now, how did it figure that out? Well, it said, well, you've got a 2001 DB82 8000/49, and you're going to go ahead and hand out 56-bit networks. That's 7 extra bits you can play with. So 2 to the power of 7 equals 128 possible networks. And currently we have no DHCP clients that have asked for prefix delegation, but we're going to change that because we're going to go over to R10. We're going to tell R10 to be a DHCP client asking for prefix delegation services. On the client, R10 acting as a DHCP client for prefix delegation, let's go ahead and go into configuration mode, and in interface gig 10, this is the interface facing our service provider. We want to enable IPv6, specify him to get an IP address through auto-config, and this is the most important part for prefix delegation right here. We want to say we want to be a client for prefix delegation, and then we issue this label. Now this label is just made up. It's on the local router itself. It doesn't have any significance other than what's inside the mind of R10. So any networks we do receive through prefix delegation, we're going to associate with this local label of from-ISP. Now, a great question is, well, Keith, I didn't see any screen activity. Did we actually get a network prefix? How would you verify that you got a prefix from R4 acting as a DHCP delegation prefix server? It's a great question, and an easy way to verify that is to use the show IPv6 DHCP interface command, and that should show us any prefixes that have been currently assigned to us. So right here we've got this beautiful prefix, DB, it's 2001 DB82 8000/56. Now we can use that /56 and we can further subdivide it and use it interior to our network. So the next question that comes up, well, how do you take this prefix you learned and associate it with your other inside interfaces? And the answer is pretty simple. What we're going to do is we're going to go to the other interfaces, like for example, gig 20. We're going to enable IPv6 on that inside interface. And then we're going to say for your IPv6 address, we want you to use this label from-ISP, which means that /56 prefix. And then where it stopped, go ahead and use the last, what would it be? 64 plus 8 more bits. Go ahead and use this for those values. So we take this in binary. This part right here is 64 bits, and this last set of zeros is really 16 bits, and 8 of those, the last 8, are being used to fill in the gaps. So we have 56 bits from the prefix we got delegated to us. The next 8 bits are represented by the last 8 bits here. That would bring us up to 64, and then we have the last 64 bits right here. Let's just take a moment and verify real quick that we actually have a working IP address on that interface. So for gig 2/0, if we look at this right here, there we go, 2001 DB82 8000. That's our 64-bit network, and the host ID is a whole bunch of zeros and a 1. And because we have those 8 bits to play with, the last 8 bits of the prefix, we could actually create 255 more possible subnets out of it. So this would be the first subnet. Let's do one more with interface gig 3/0. So we'll make a road trip into gig 3/0, and on that interface, we'll simply say, you know what? We want you to be enabled for IPv6. We're going to use that same tag for the delegated prefixes that we learned, except this time we're going to put a 1 right here. So the last 8 bits that we're filling out, let's go ahead and do a show command real quick. The last 8 bits that we're filling out are going to be 00000001. And that's what that digit right there represents. So now we have 2 inside interfaces. One is a subnet of 8000, the other is a subnet of 8001. And the cool thing is, the service provider, when he assigned us that /56, he actually put on a static route. So we went back to the service provider and did a show IPv6 route and just looked for the static routes. We would have this static route that says, you know what? To get to this block of addresses, 2001 DB82 8000/56, which includes all the new subnets that customer R10 is going to create under that space, go ahead and send it out gig 20, which goes in the direction of R10. In this MicroNugget, we've taken a look at one of the options for doing prefix delegation with IPv6. We took a look at why it's useful, because we need to hand out IP addresses to customers. We identified the basic components of one way of configuring it using pools and DHCP, and we looked at verifying it as well with show commands. I hope this information has been informative for you, and I'd like to thank you for viewing.